So the first part of today's new lesson is about rectilinear motion and how you can use definite integrals. So two things I want you to note on your pass out. Displacement is the integral from A to B of velocity. And if you were looking at a graph, it's A1 minus A2 plus A3. So basically, you're accumulating the areas. This is negative because it's under the x-axis. Or you could just evaluate a definite integral using your power rule or your calculator. Now, total distance is the integral from A to B of the absolute value of velocity. So if you were looking at a graph, you would flip this negative part up as positive if you were on a non-calculator part. If you were on a calculator part, you can use your Math 9 or you can use your power rules. Notice the difference. Displacement is the position relative to your starting position. So where you ended up. And total distance is the distance that you traveled. So let's look at some examples. So if you look at this example, it's a particle that's moving along a line, so that's velocity v of t equal t to the third minus 10t squared plus 29t minus 20 feet per second at time t. What is the displacement of the particle on the time interval of 1 to 5? And then B, what is the total distance traveled? So if you were doing it using your power rule, part A, the displacement would be 1 to 5 v of t. And you could see how you'd work it out and evaluate it at 5 minus evaluating it at 1. And you get 32 thirds. If you are doing the area, if you're doing the distance, you want to see where the x-intercept is if you're going to do it using your power rule way, because you want to negate out your distance that is down here, because this will be under the x-axis. So you would run from 1 to 4 v of t, and you would do the same thing you would do up here, minus 4 to 5, and use your same power rule. And if you did, you could get 71.6. But I want to show you using your calculator so you can see how you would get the same thing. So let me get your calculator and show you. So you're going to do, for part A, the displacement, you're going to do Math 9 and then do integral 1 to 5. And we're going to type our original function. So x raised to the third minus 10x squared plus 29x minus 20. And then you're going to put dx, and you're going to get 10.666, which, if you look on your paper, that is the same thing as 32 thirds. Now, let's try part B, the distance. So you're going to do Math 9 again. And we're going from 1 to 5. But we need to put our absolute value bar, so you're going to do Math, arrow over to num, then pick number 1, the absolute value bars. Now we're going to type exactly what we did before. X raised to the third minus 10 x squared plus 29x minus 20. Slide over and put your x and hit enter. and you're going to get 11.8, which if you look on your handout is the same thing as 71.6. And most of your free response will allow you to use the calculator on this. So let's do a couple of free response with this. And again, follow along on your sheet so you can see better. So you've got a particle moves along the y-axis with a velocity given by v of t equal t sine t squared for t greater than or equal to 0. And this was a calculator active. So part A, it says which direction, up or down, is the particle moving at time t equal 1.5 y. So remember, you know which direction it's moving based on the sign of velocity. So you're going to put v of 1.5, and you can either type it in a regular screen, or you can type your original function in y equal and look 1.5 up, and you'll get 1.1671. So that means it's moving up because velocity is positive. Now part B says find the acceleration of the particle at time equal t equal 1.5. Is the velocity of the particle increasing at that time? Why or why not? So remember, first derivative of velocity is acceleration. And since this is a calculator active, we can use our calculator. And let's do that. So acceleration is the derivative of velocity. So that is math 8. And this will come up. And of course, we're going to use x. And then we're going to type x times sine of x squared. And you tell it 1.5. And you're going to get negative 2.049 if you round up. So we know the particle velocity is decreasing because the first derivative of velocity, which is acceleration, is negative. And remember, if your first derivative is negative, it means your original function is decreasing. Now part C, it says given that y of t is the position of the particle and y of z equal 3, find y of 2. So you first have to integrate to get your position function, because remember, you're working backwards. So we're going to integrate t sine t squared dt. We can't use our calculator here because it's not a definite integral. So I'm going to let u be t squared, du be 2t dt. And so if I'm putting a 2 inside, I'm going to put a 1/2 out. And then when I take the integral of sine, it's negative cosine of u, and then I've got my 1/2 plus c. So then I'm going to use the fact that they told me y of 0 equal 3. So I'm going to plug 0 in for t, set it equal to 3, solve for c. And I get c equals 7/2. So now I want to know what s of 2 is. So I'm just going to plug 2 in, and I get 3.8268. Now, let's talk about finding the total distance. We're going to use our calculator for that, and they want to know the total distance from 0 to 2. So to get the total distance, we're going to use math 9 from 0 to 2. Remember to use your absolute value bars, and you're going to get 1.173. Excuse me. Our next example, and follow along where you can see better on your own paper. We have two runners, A and B. The graph reflects runner A and the function, the velocity of runner A, and the velocity of runner B is by this function rule. And it's from 0 to 10 seconds. And the velocity is in meters per second. And so part A says find the velocity of runner A and the velocity of runner B at time equal 2. So velocity A, you're just going to look at the graph, and it's somewhere between 6 and 7. So I said approximately 6.6. You could have put 6.5 meters per second. And for runner B, I'm just going to plug 2 in, work it out, and you're going to get 6.8 meters per second. Now, part B wants to know the acceleration of runner A and B at t equal 2. And remember that acceleration is the first derivative of velocity. So if you look at the graph, the way you're going to get the derivative of this is to take the slope. So I just used the 2 endpoints because it'll be the same slope of that line for the value of that point too. So if you do the slope formula, you get 10/3 meter per second squared. Notice it's second squared because you got meters per second divided by seconds. And the first derivative of 2, you're going to use math 8. And so you will just plug in and you will get 1.469 meters per second squared. Now part C wants to know the total distance from A to B. So on A you have a graph, so you're going to do 0, 10, the absolute value of V of t. We don't have to worry about any negative flipping it up because we don't have any negative on this graph. So we're going to look at the geometric shape from 0 to 10 since we don't have a function rule, and that is a trapezoid. So if you do 1/2, 10, 10 plus 7, you get 85 meters. Now runner B, you can use math 9, remember your absolute value bars, and you get 83.336 meters.